my final answer. What?
Y equals A times BX.
Exactly. So I'm going to do y equals a times b to the x. All right? Now, how do I do that? Who remembers?
Yeah, I said.
So my first point is 0, 10.
So 10 is your.
So 10 is your a. So now we're all ready to here.
Plug it in.
So then we plug in the other point, 45/8, so let's not freak out, equals 10 b to the second.
Square root?
Divide.
Oh, no, you
No
divide.
square root.
divide,
First I
divide.
have to either, it's up to you, divide by 10 or multiply by 1/10. Won't that accomplish the same thing?
Yeah.
And it might be easier since this is a fraction.
Yep.
So b squared equals, now you can go ahead and multiply and reduce,
Sure.
or you can cross cancel. And it looks like it works out to be 9/16,
No.
which is an absolutely magnificent number to have, because I'm going to square root.
3 or 4.
So my answer is y equals 10 times 3/4 to the x,
Okay.
right? Number 2, sketch. Okay, tell me what's going through your mind here. What?
Well, I think it's decay.
Well, it's going to be decay, because isn't this the same as 1/2 to the x? So my sketch is going to be a decay like this.
Yeah, 0 is the asymptote.
0 is going to be the asymptote. I got paper. 0 is going to be the asymptote, and that's it. And it's just a quick sketch, so nothing has to be perfect. All right, how about this one? -2 to the x plus 1. Now, guys, this does not flip, or this does not become 1/2. It's not the exponent that's negative. If that weren't there and that weren't there, what does y equals 2 to the x look like? Just y equals 2 to the x.
It's a line.
That's not a line. It's growth, isn't it?
Yeah.
Isn't that what it looks like?
Yeah.
Okay, so what's that do to it?
Negative.
Flip it upside down. So now I've got this. So I'm gonna erase the original. This was the original. Now I've got this. Now what is that gonna do? Raise it 1. So remember, just like over here, the original asymptote was at 0, but now that asymptote is gonna be at y equals 1, and we're gonna have a picture that looks like this. So the red one is our final answer. Is that all right with everybody? All right, number 3. Find the y-intercept and horizontal asymptote. Stop it. This is easy. How do you find a y-intercept no matter what the equation is? How do you find the y-intercept? You let x be 0. So I've got 1/2 to the 0 minus 1. So what's 1/2 to the 0? 1. 15 minus 1 is 14. So my y-intercept is 0, 14. Guys, I don't care what the equation is. It can have sines and cosines and logarithms and everything in it. If you want the y-intercept, you let x be 0, period. Okay, now, asymptotes. All right, so let's think about what the original problem looks like. So let's start right here. What does that part look like right here? This right, just this.
Decay.
That's decay. Now, timesing it by a positive number makes it steeper, but it doesn't move it or change it in any way other than it makes it steeper. That, however, does. So what does that do? Drops it down. So now the asymptote that used to be at 0 is now at -1. So your horizontal asymptote for problem A, or the first one, is y equals -1. It is easy. All right, let's look at the next one. Now the next one is a logistic function. So a logistic function, remember what they look like, is actually gonna have two asymptotes,
A limit to growth.
right? It's gonna have a limit to growth asymptote, and then what's its bottom asymptote? 0. So it's gonna have one at 0 and one at its limit to growth.
Oh, so we already know one.
Okay, so I'm doing asymptotes now. My bottom asymptote's gonna be 0. And my top asymptote is going to be, what's my limit to growth? 12. So there are your asymptotes, done. Logistic, two asymptotes, top and bottom. Now, how do we find the y-intercept?
Set x equals 0.
Yep, put in 0. And I'm not gonna panic. My gosh, what's 0.7 to the 0? 1. So I have 12 over 1 plus 3, which is 12 over 4. So my my y-intercept is 0, 3. Now, oh shoot, I erased some. Okay, so remind me, y equals 2 to the -x. That was 1/2 to the x. And so it looks like this. Okay, I'm answering question number 4, which is referring me back to number 2. Most of you missed this in the homework. So I'm gonna take the blame. I did a bad job of instruction. I'm gonna fix that right now. When it talks about end behavior, we have to use the correct notation. The end behavior, forget the picture of matter. The end behavior of anything is gonna be the limit as x approaches infinity, and the limit as x approaches negative infinity of your function, whatever it is. In our case, this is our function. End behavior means what happens on that end, positive infinity, what happens on that end, negative infinity. This is the notation we use all the time, period. Okay, so then we look at our picture. X approaches positive infinity means we're going that way. What happens? 0 from the top. Very, very good. That curve is coming in towards 0 on the top side. What's happening on the left? Infinity. That is your end behavior for that picture. Now, we still have to do the second one. What was our picture for the second one? Well, it started out being 2 to the x, but then I flipped it over, and then I moved it up 2, or up 1, I mean. So it ended up, is this right, looking like that? The second one in number 2?
Yeah.
And this was y equals 1? So we're doing our end behavior. So always, the end behavior is the limit as x approaches infinity of my function, and the limit as x approaches negative infinity of my function.
Negative or negative.
So what's happening to the right?
Negative.
It's going down. So if it's going down, I'm going to say negative infinity. So on the right side, x going to infinity. My curve is going down. What's it doing on the right side?
What's that again?
It's heading toward it's heading toward 1
One
Minus.
from the bottom side. This is positive 1. It's coming in toward 1 from the bottom this time. This one was coming into its asymptote from the top,
What do you like call that? Like that?
coming in towards 1 from the bottom.
Okay.
Yep. All right, number 5. Does this represent growth or decay?
That's decay.
That's decay. How do we know it's decay?
Or less than 1.
The ratio, which is 0.947, the thing with the x, the base, is less than 1. How much less than 1 is it?
0.053.
0.053, which is what percent?
5.3%.
5.3%. So what is the percent growth or decay? It's a 5.3% decay. Where did that 5.3 come from, boys and girls?
1 minus 9.9.
Exactly. 1 minus 0.947.
Sure.
Okay, all right. Number 6. The population of athletes after T days is given by this equation. What is the initial population of athletes? Okay, now, I know you all want to look at that and give me some number that's in it, and you are wrong. If we want the initial value, that is what happens when t is 0. That's your y-intercept. What do I get when I put in 0 for t? So 1001 over 1 plus 90 times e to the 0?
91.
So it's 1001 over 91?
Yeah.
Is that 11? So what is the initial population? 11 athletes. Okay, so let's make sure we're clear on that. How do we find the initial value? We let t or x be 0 because that's the beginning. That's time 0. That's the start. What is the maximum population of athletes? That's your 1001 because that is your limit to growth,
Yeah.
right? So that's 1001. When will there be 332 mathletes in the city? So in other words, you want this to be 332?
Yeah.
So let's get our calculators out. Jack? Is that yours or did you take it out of the thing?
No, it's the same thing.
All right, and I'm going to graph and solve by intersections,
Yeah.
okay? So I'm gonna put in, this is gonna be one equation, and that's gonna be my other equation,
What's the other one?
332. 332 is one of them, and the other one is 1001
Gosh darn it.
divided by, if your calculator is old like mine, then you have to, when you do divided by, you have to put that in parentheses.
Whoops.
If you have a newer calculator that gives you a fraction option, then you don't need to worry about it,
Hashtag lucky.
but I have to worry about it. You already have the answer?
Look who it is.
You know, you didn't hit right now?
12.6.
Vincent,
4 days.
did you tell him he can handwrite his paper?
I thought I could handwrite my paper.
But then you learned in class today,
So I
this
read it.
morning, when did you tell him?
I didn't. It's not my fault, bro.
That's
Hey, bring that on me.
That's where you put your great credit. You put your great hand in this.
I'm going late, bro. Ain't my fault.
He's never fast. Got another paper printed out? I think everybody has that.
Alright, I don't know what you got, I got T equal to 12.664. Anybody else get that?
Yes.
So, what does that mean? That's 12.664 days? So after about 12 days?
Yeah,
we'll
what,
be up to
yeah.
332?
Is that what you'd want us to put?
Huh?
Is that what we would put?
Well, it depends what the rounding instructions were. So 12.664 days.
You want us to be exact, but it doesn't say?
Well, we can't be exactly rounding off, but yeah.
In a moment, it was like 13, you'll start slowing down.
No, well, I don't know. When, maybe, is that when it starts going down?
Yes.
Okay. Actually, this isn't gonna go down. This is a logistic function. So this is 1,001 up here. So it's gonna keep going up. It's just never gonna get up to 1,001.
So it's never on 5.
No, it's just gonna keep getting bigger and bigger, but you're gonna get, 1,000.5, and then you're gonna get 1,000.6, 1,000.99, 1,000. You're gonna keep getting closer to 1,000.
Where are you looking?
All right, finally, number 7. The number of bacteria present after time t minutes is given by this equation. Okay. Find the number of bacteria present after 11 minutes. So we just plug in 11 for our t.
Yeah.
We don't graph this one, we just plug in this one. Wow, did you get 11,711?
Yeah.
Now that one I am rounding off because this is bacteria. Can I have a half a bacteria?
No, maybe.
I don't know.
I don't know.
We'll leave that to the biologists.
Okay.
If it's people or animals or something, it's gonna be whole things. Years, can we have half a year? Sure. Yeah. All right, when will the number of bacteria be double what we started with? Well, look at your equation. What did we start with? 200.
So you put 4.
200.
Yeah.
So now we're going to set this equal to 400. Now, a little hint, I'll leave it up to you, it's completely up to you. Before we start graphing, we could divide everything by 200 and then just graph 2 as one of our equations and e to the 0.37t as the other one. It isn't going to make a difference, it'll change your window, but it won't make a difference in your answer. You will get exactly the same answer. And I got,
1.87.
you guys are fast.
Yeah. You know me.
I know you, gonna wait on the old lady here, let's see. I got, what did you say you got?
1.8734 minutes.
I got 1.873, and it says when will that happen? After 1.8 minutes. Oh my gosh, you guys. So this population is doubling every 1.8 minutes.
That's a lot.
It's a lot. Have any of you ever had food poisoning?
I just had it.
That's how they grow. They grow super fast. You eat a few of those little bad guys, and they really get going. Okay, right, everybody got that good here? All right. On, next time I see you, what, Tuesday? We're gonna do some more practice, and then right after Thanksgiving, we're gonna have a little quizzy quiz. Okay?
Right
So
after,
you'll
like,
have time, yes.
Yes. So you should study.
Yes.
Study.
the Monday coming back.
Probably, is that our day back? Yeah, yeah. No whining and complaining. Remember, you're in the running to be my favorite class. Let's keep that going. No whining and complaining. Okay, get your notes out. We are going to finish, maybe, I don't know if we're finished 3-5 today, I think we will. All right, so here we go. We're in our notes, 3-5. And we are on problem 3F. So we're at the bottom of page 37, doing the last problem. All right, everybody okay? Now, we started talking about this yesterday. All right, we started talking about these yesterday. And tell me,
Combine those first.
Okay, all the logs.
Combine those first.
we gotta combine these. Guys, I'm gonna say it again. You, me, any math teacher in this hallway, nobody can solve this equation until you put these two together.
Yeah.
So when I put them together into one logarithm, now this one's okay. I can have one on each side. So he's okay. But these two are gonna come together, and what's gonna go in the parentheses?
4x.
4x. Now, as soon as I have log of
You can cancel.
left equals log of right, then these can be gone, and I have 4x equals x minus 2.
Yep.
So 3x equals negative 2,
Wow.
and x equals negative 2/3.
You guys in the track? Hold up. Got your work, buddy.
Okay, are you done with your visit?
Yeah.
Then why don't you just stay and join us?
Huh?
Hmm?
Why would I stay for 15 minutes?
Dana, I already turned mine in.
All right.
I already printed mine.
I'm gonna get
Well,
two
you're gonna learn
copies
some
of yours.
valuable stuff.
No,
Dave,
he
if
didn't.
you-
All right, now, we need to go back. This is actually an extraneous root. Why is it extraneous? Because I can't take the log of a negative number. So if you plug, like if you type on your calculator, log negative something, doesn't matter, 2/3, 15, doesn't matter, it isn't gonna work.
There's no solution.
No solution. This problem has no solution. The only answer came out to be extraneous. Sam,
So I know in a subtraction, it's division, but would it be, like in that case, say it was a subtraction instead of addition, would it be x over 4 or 4 over x?
it'd be first over second.
First over second.
Because our
Now, yeah. And, okay, now I need to clear up what Elijah just said over here. I think he knows what he's saying, but I wanna make sure nobody heard him incorrectly. I'm not crossing this out because it's a negative number. I'm crossing it out because when I put it back into my problem, I would have to take the log of a negative number. Now, here's what I mean. Suppose instead of being x, this had been x plus 5,
Well, then we're
and
chilling.
this had been x plus 2.
Then we're fine.
Then we're fine.
We're good.
Because when I plug it back in, this would be positive.
3, 4.
That's what can't be negative, do you understand?
Yeah.
It's not the number itself, it's when you plug it back in, okay?
Gotcha.
All right. Okay, backside, we're gonna skip to H. 400 over 1 plus 95 e to the negative 0.6x equals 150. Now, I need you paying attention. We actually just did one of these on our calculator, and Nathan, Owen, it, one of you is typing it in, gonna graph it, and find the intersection. I want to go through with you how we do this without graphing, all right? Because it's good solving practice, all right? So here we go.
I mean, you're not wrong, you know.
Take a look at it. The first thing I think you ought to do is multiply this thing over here to this side. Okay? So bring the denominator over here with the 150. Does that make sense? Now, what kind of makes sense to do now? Distribute. So 400 equals 150 plus, stop it, 14,250 e to the negative 0.6x. So, everybody with me so far? So what did I do first? Multiplied the denominator, put it as a fraction. Then I distributed, because that's what I have going on here. Now I heard somebody say, could I divide? You can, but you're gonna get a fraction then. So it's probably easier not to, but it's up to you. All right, now we're gonna subtract the 150. So 250 equals 14250 e to the negative 0.6x. Now we solved some equations like this yesterday. No, not yet. First I have to divide by that big number. Remember, we don't do the ln thing until this is gone. So I have 250 over 14250 equals e to the negative 0.6x. Now, I know that reduces. Go ahead and reduce it if you want, but you don't need to, because in a moment, what are we gonna do anyhow?
Plug it in.
Plug it into the calculator, so I just leave it. Okay, at this point, we're gonna ln. So I'm gonna have ln, this big fraction, and then what happens over here? Those are gone, and all I have left is negative 0.6x. So then I'm gonna take all of this and divide it by negative 0.6. So ln 250 divided by 14250. And then I'm gonna divide that by negative 0.6. And I got 6.738.
That's what I got. Hold on, let me see it one more time. Okay. All my fractions
So, just for fun, let's go back to the original. Let's go ahead and graph, like you were gonna do anyway. So let's graph 400 divided by parentheses, if you need them, you have my kind of calculator. And 150. Charlie, you're irritating me. How do I feel about people who just sit around and don't do anything?
Oh, my calculator's dead. Shouldn't say it.
Oh my god.
When was the last time you went to a tennis match without a racket?
Whoa.
He he got you with
Same
that
thing,
one.
all right?
Hey.
And I'm gonna have as much patience as your coach is gonna have. I have none, zero.
Oh.
All right, right, Jack?
Yep.
I just graphed it. I don't know if you did or not. I got exactly the same answer. Of course. That's the right answer, right?
What did you put in the graph? ln
This was
that.
one equation, and this was the other, way back at the beginning. All right, so now I want everybody to skip down to J. And I want you to do J by hand, not by graphing. I want you to go through this process with J. So help each other, you can help each other.
We don't need a calculator
Well, you're going at the end. When you get very to the very end, you will. But you don't need a calculator as you're working through it.
200.
Jay, which is 200 plus 5,000 times 2 plus 10. Can you tell me that?
So now,
Subtracting 200 over, so it's 300.
Remember, you guys, if your calculator has your name on it, and I have Sharpies, so you're welcome to use my Sharpies. You can come in the morning, pop it in the charger, and it'll be ready when you come to class. Okay? Anytime, you're welcome to do that.
Divided by, see, this thing don't charge. 5,000?
Honey, that one isn't a chargeable calculator, that has batteries.
No, it's good, it's just,
No, I don't know that that's a charging, I think that's a hook it up to the computer thing.
That's where you online
This has batteries, which are available at CVS.
okay, got it.
Okay, I love that.
Negative 9.278. Did you get that?
I was going to wait, saying you get LN, I wonder how we're set up.
Yeah.
What does X?
Okay. Negative 9.378.
Wait, how do you like when you use ID in the LN? In your calculator?
You said L1.
No, LN, and then you take
300
Okay,
divided by 5,000.
was the first thing you did, was the very first thing you did,
Joe, why would you
multiply
break-
this over here?
Yeah.
So did you end up with this?
Yeah.
With you guys.
So then I hope you subtracted
Yeah.
200
Oh, I remember.
Yeah.
and then divided by 5,000. And again, you know these zeros are gonna cancel, so it's perfectly okay to cancel it if you want to. You don't have to though. And then,
Whoa. Gosh. Count down.
what now?
Alright.
And then now you put
LN both sides.
Cancel out.
And divide by
0.3.
0.3. Now I reduced, you don't have to.
Yeah, I agree.
Leave it 300 over 5,000 if you want.
Same thing.
Not gonna matter, yep.
Yeah.
So I heard somebody say this number earlier and you were right.
Negative 9.378.
Negative
Negative
9.378. All right.
One above it though, I don't know about that.
Yeah, I know, we're not, I gotta talk to the other ladies.
That one was kinda hard.
G and I are really tough, I wanna see if we want to take class time to do that. But we do have one more thing, we have 5 minutes, we have one more thing to talk about. Remember your bonus on your quiz that you all just struggled so mightily with. What? I know, it's crazy. So, we're gonna have a logistic function So that's step one. Some of you forgot what a logistic function looks like. That's what it looks like. And then the initial value is 25. That's that point right there. That's the initial point. And then the limit to growth is 100, and that is that number, the limit to growth. And f of 4 is 149.
So we did that wrong.
Okay?
So in an exponential function, a is the initial value.
Yep.
In logistic
Yep.
function, a is the y-intercept. Or no.
Yeah. But the initial value is the y-intercept all the time. It just so happens that in the exponential, it shows up in the exponential. All right, so if I put in a 0 here, I'm supposed to get 25 here, right? So 100, 100 over 1 plus b equals 25. So 25 plus 25b equals 100, 25b equals 75, b equals 3.
Yes.
So now, I know b is 3. So then I'll plug in my other point, which I erased, 149ths equals 100 over 1 plus 3c to the 4th.
Yes.
Now this is even easier than usual. See how those are both 100?
Yeah.
Doesn't that mean 49 has to be 1 plus 3c to the 4th?
Yeah. Yeah.
Now, you can't do that unless they're the same thing, and they happen to be the same. So 48 equals 3c to the 4th, 16 equals c to the 4th, and c.
Oh, what if they were different?
Then it would cross multiply.
Okay.
And there's your equation.
What the sigma?
All right?
Wait, what if you plug both of them into a function? Like you plug 100 over the n and the y1 and 100 over 1 plus 2c
Yep.
to the 4th.
You can always solve by intersections if you have a calculator to graph. If all you have is a baby calculator, that's not gonna work.